live captions. Now, I've turned off chapter 1 homework. I think I have, because I don't want you to do it. Why? Because I'm going to cut out some of it. I'm going to cut out some of chapter 1 homework. So please do not do any chapter 1 homework. Okay, now what I cover today, I'll fix you some homework, but don't do any unless you see Hubert's chapter 1 revised or something like that homework. Do not do, let's see if it's, I don't even know if it's up, shouldn't be. When you pull up your handy dandy homework, you should only see past event, past homework. Yep, good. So that way all our people that want to try to go ahead, they can. Good. All right, now what I'm going to try to do is I'm going to try to curtail 1.1 through 1.3. I'm going to try to make that one homework. Why? I'm pragmatic, okay? I don't believe in taking you around the world to tell you how to get to your house. So I'm going to try to narrow down this into the important stuff of, turn your speakers down, please, of limits. So I'm going to try to get this. It'll be called Limit Homework Revised or something like that. It might have 1.1 through 1.3. Does everybody understand that?
Yep.
Now, 1.4 through 1.7 is 100% important. That's your calculus. So where is 80% of your test going to come from? Right here. 1.4 through 1.7. So tonight, sometime tonight, I will create a 1.1 through 1.3 limits homework revised. I do this with the 140 and I do it with the 130. Why? Because we don't need to spend 2 to 3 weeks on limits. Does everybody understand that? You need to understand the concept of limits, and you need to understand what it means, but you don't need to spend 3 sections of homework on limits. Anybody got a question? So please just be patient with me, and you'll see the homework pop up. You'll see it eventually. I don't need anybody, right, Mr. Bostic? I don't need anybody telling this. I don't need anybody telling me that the homework's not up, okay? I will get it up. I'll get the 1.1 through 1.3 homework up. Now, what is limits? Well, as I talked to you before, and I told you we did difference quotient, right? Yes or no? Difference quotient?
Yes. I believe so.
I thought we did. Okay, so I'm going to explain it to you again. Difference quotient is nothing but the what? The slope. And that is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Sophisticated, m is equal to f of x plus h minus
Priority 1 message
f of
coming in
x
on secured channel
over h. These two are the same. Okay, this is algebra. Limit theory. Limit theory is what they're going to try to teach you in 1.1 through 1.3. But basically, limit means convergence. Convergence. In other words, if this is a wall, you know wall spelled backwards is law. Wall, that's wall. Okay? And I tell you to take a half a step toward that wall. And let's say you got a 4-foot stride. And then I tell you, after that, take half of the previous step. Half of that. Half of that. Half of that. Half of that. Will you ever reach the wall?
No.
No.
I will be right back.
You will not reach the wall. That is limit theory. You will never reach the wall. Now, you might get right up next to it, but you will never, ever reach the wall mathematically. Because this is 1/32nd, 1/64th, and so on. Your steps get smaller and smaller. You never will reach the wall. That is limit theory. You put that with this, and you got calculus. All right? Here is the example I showed y'all before. You got a curve. You put a line between P and Q. And that is called the secant line. The distance between H and that second point is H. And you turn, and as H approaches X, as the distance between, as H is equal to 0, as that, you taking half a step, 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 you get right up next to X. You're turning the secant line into the tangent line. That is calculus right here. This is calculus. H goes to 0. And you're turning, when H goes to 0, you're turning the secant line into the tangent line. Now, that may not seem a lot to you right now. That may not, but the tangent line in calculus and physics and business, the tangent line in calc apps, applications, is very important. As I told you, physics, statics, dynamics, and not only engineering, but you also talking about economics. Oh man, I can't spell. You studying curves and finding the vertex and finding the tangent. That means a lot because the tangent line at the vertex, the slope is 0. Write that down. The tangent at the vertex, and in business that means an absolute high or an absolute what? Low. The tangent line is, the slope is equal to 0. That's important for you marketing people, for you marketing, business, whatever. So it's very important that you find the tangent line. Now, as I said, the limit means convergence. If you look at this picture again, and you approach from the left and the right, Does anybody know what that's called in calculus when you converge onto a point from the left and the right? Does anybody remember that from calculus? Let's say that this point, I don't know if I can move it. No, I can't. I was going to try to move it. Let's say that that point right here, well, you're approaching 2 in the x and the y in the x direction. And we'll just take that. I'm going to draw this on the board. I'm on the whiteboard here. And let's say, for all practical purposes, just give me a second to draw this. Okay, here's that picture right here. Now, the limit theory works this way. Limit can approach from the left or the right. The limit can approach from the left and the right on the x-axis. The limit, as x approaches a number, will be the y. What are you talking about, Hubert? Well, let's say that I tell you that I want you to find, let's say this is f of x, and I want you to limit as x approaches 2 from the right of f of x. So that means I'm going to cover up the left-hand side because this is 2 right here. And I'm going to approach, I'm going to take my step, half a step, half a step, half a step, and I'm going to approach this wall right here. Now, as I approach this wall, what's happening up here? I'm going what? I'm going down this hill. Everybody with me? And as I approach this wall, I get closer and closer to my distance, to my 2. And I am approaching y is equal to what? 2. Now, it's very important that you understand what I'm talking about here, because this is 1.1 through 1.3. So I just approached 2 from the right, from little man, half a step here, half a step of the previous step, half a step of the previous step, half a step, and I'm approaching 2 from the right. As I approach 2 from the right, my graph is coming downhill, it's decreasing until I get to 2. When I get to 2, I'm approaching 2 in the y direction. So the limit as x approaches 2 from the right is 2. So this says, as I approach x equal 2 from the right, I'm approaching y is equal to 2. Does everybody understand that? Because I'm going to tell you something. Limits can be confusing. It all depends on how it's presented. So now I take my handy dandy pink marker, and now I do limit of f of x, of the function, as x approaches 2 from the left. So I start from 0. I take half of that step. I take half of that step. I take half of that step, half of that step, half of that step, half of that step, half of that step. Get down here, and I'm approaching. My steps are getting smaller and smaller. What's happening here? My function is decreasing, and I'm approaching y is equal to 2. So that's going to be equal to 2. What happens if the function is equal on both? Well, that's what I'm going to take my pink highlighter. Well, I shouldn't have used pink. I'm going to use my green highlighter. If these two numbers, if these two numbers equal, then you write down, and I'm going to put this in red, the limit does what? The limit exists. Write that down. If the two numbers equal, the limit exists. And this is called, anybody know what this is called in calculus? This is called the Squeeze Theorem. Anybody ever heard that before? Yes or no?
Yes.
Where'd you hear it? Pre-calculus?
AP calculus in high school.
And basically, it's when you're approaching, if the x, see the x on the right and the x on the left, they're approaching the x. They're walking toward the wall, half a step of half a step, a half a step, a half a step. And what's happening? The R and the Q is approaching what? Well, let's just say 2. I use 2, but it's basically 1 3/4. All right, it's approaching this y right here. That's called the Squeeze Theorem. And if the two limits are approaching the same y, then the limit exists. That is a test question. Make sure you understand what I just wrote. If the limit from the right and the left approaches the same y, the limit does what? It exists. All right, let me show you another one. These are graphic representations, and you will see one of each on the test. Let's say I give you this one. And I do f of x. Let me do f of x, and let me use different colors, orange. Let's do f of x, and I'm going to put a dot right there, and a dot right there, and that's f of x. And then I take my green marker, and I put a line right there. And let's say that this is 2. And let's say 1, 2, 3. Let's say that that's at 3, give or take a millimeter. And this is at 1. So I'm going to write in green, limit as h or x approaches 2 from the right. And then limit as x approaches 2 from the left. Let's say that's f of x, this is g of x. Sorry, I've done messed it up. G of x, there we go. And this is f of x. Okay, so let's approach. I'm approaching 2 from the left. There's my man. Half a step, half a step, half a step, half a step, half a step. half step, half step, half step, half step. We're going real tippy toe now. As I approach, what's happening here? I'm decreasing, but why am I approaching? 1. Everybody with me? So that's equal to 1. What am I approaching? Here's my man. And I'm approaching, and I'm getting smaller and smaller and smaller and smaller and smaller. I'm approaching 2 from the left. What am I doing? I'm approaching what number in the Y? 3. Are these 2 equal? Does 1 equal 3?
No.
So therefore, the limit does not what? Exist. Now, those are 2 type questions that I would ask you on the test from 1.1 and 1.3 right there. That's what I would ask you. I'd give you a function, and I would ask you if the limit exists or if it does not exist. And we'll go over a couple more. Then there's the algebraic limits. What's an algebraic limit, Hubert? Well, an algebraic limit is when you don't look at a graph, you just do an algebraic limit. Or you just do it algebraically. I hope I spelled that right. Limit as x approaches 4 of x squared plus 2. Somebody tell me what the limit is. That means I want somebody to say something. Either I don't know, I don't remember, I hate myself, something. Say
18.
something. 18. What did I do with that 4? I plugged and what? Plugged and chugged. Let's do another one. Limit as x approaches negative 1/2 of x cubed. Of course, y'all wouldn't do this one. Why wouldn't you do this one? Because it's a fraction and y'all run away from fractions. But for those of you that don't run away from fractions, is equal to negative what? 1/8. That's an algebraic fraction. I mean, an algebraic limit. Real simple. This is what I'll ask you on a test. Now let's do one that doesn't come out so simple. Not so simple. Now, I think I told y'all that these are pretty simple, right? That's pretty simple, straightforward. These are pretty simple and straightforward. You just have to think outside of the box a little bit. Those are pretty simple and straightforward. Well, sometimes you're going to get one that looks like this. Limit as x approaches 2 of x squared minus 4 over x minus 2. Now, what's the first thing you're going to do here? Plug and chug. What happens? What happens when you plug and chug?
It's 0.
Oh, the function blows up and you can't do it. So you put does not exist. Nope. When you get one that's not so simple, usually you have a lot of algebra involved. Okay, you have a lot of x's involved. Number one thing to do. Factor. This is shortcut number 3, the difference of two squares. Limit as x approaches 2 of x plus 2, x minus 2 over x minus 2. Now what? The x minus 2's do what? They cancel, Hubert. Thank you, class. Appreciate the interaction.
Yeah, they cancel.
Thanks, 2 hours late. So what is the limit of x plus 2 as x approaches 2?
Four.
Thank you.
Yeah, 4.
Yeah, you want to graduate from Clemson, won't you, Mr. Bostic? Yes, yes, yeah. Yeah, 4. Yeah. All right. You'll say every sentence. That's what most people that graduate from Clemson say.
Hey,
right.
you did.
Huh? I know. I say okay all the time. That's my nervous tick. Okay. Okay. Oh, I forgot to turn my video on. I'm sorry. I do that for a reason because I can see everybody's video unless I turn mine on and it jumps in there with y'all's, messes up the. I'll just do ceiling fan. There you go. All right. So, what do you need to write down about this one? Well, you need to write down, and this is very important because it will get you on a test. This right here means you have an open circle at x is equal to 2 and y is equal to 2 squared is what? I mean, you have a vertical asymptote. I'm sorry. You have a vertical asymptote at x is equal to 2. A vertical asymptote at x is equal to 2. So that means it can either be a vertical asymptote or it can be an open circle. It can be one of those two. So let's just graph this and let's see. So x squared, let's clear, y is equal to, let me clear these. And let's do parentheses, x squared minus 2. Remember to please mute if you have to, please. Divided by parentheses x minus 2. Now watch what happens when I graph it. And it goes quirky around x is equal to 2. So let's blow it up. Zoom 6. See, at x is equal to 2, you got a vertical asymptote. How do I know? Well, I'm going to show you a trick I learned in the war. Take that x up there. I'm going to put a dashed line. And it's going to be, let's make it pink. Magenta. And we're going to make it into, I can't make it dotted. That sucks. Damn Russians. And I'm going to put x is equal to 2 and graph. And there is your vertical asymptote. Okay, so when you're doing, I call these not so simple algebraic. When you're doing a not so simple algebraic, which means you got to do a lot of factoring or a lot of algebra, always remember that that denominator is going to represent an open circle or a what? vertical asymptote. Please don't forget that, because you will do this on the test. You will do all this on the test, and you'll get 4, and you'll get it wrong because it's supposed to be 4 with a vertical asymptote, but x is equal to 2. And I don't want you to miss this question. Now, there's also one other thing you need to remember about limits. And you need to remember that if a limit goes to infinity, the limit does not exist unless you have infinity equals infinity. Okay, so if you have two functions that go to infinity, then the limit does exist. But if you have them go in two different directions, they do not exist, unless they're going to infinity. And you'll see that with some of the homework questions. Now I'm going to go into the homework, and I'm going to look at a couple of, not the homework, because I'm going to go into what we call a study plan, and I can show you some of these problems and what I would put on a test as far as the 10 or 20% that I would put on a test. I'll show you what kind of questions they would be. So, no, that's not what I want. I want chapter contents. I hate when they change these things around. They used to have something called chapter contents, but now they done changed it. And that's not what I want. Let me go to chapter 1, 1.1, and study plan. I'm going to go through each 1.1, 1.2. How many of you have ever sat through a pre-calculus or a calculus class and were lobotomized with the limits? Anybody? Y'all lying. All right, so let's look at some. Here's one. The limit does not exist. Why? Because as I approach 4 from the left, I approach 8. And when I approach, or 5, I'm sorry, when I approach 5 from the left, I approach 8. When I approach 5 from the right, I approach what? -2. 8 does not equal -2. So therefore, this limit does not exist. That bullcrap, it does exist. How can they tell me that it exists? That's not true. Select the correct choice. Oh, h of x. Is h of x on the left side? As h approaches 7, I'm sorry. As h approaches 7, I'm sorry, I didn't read the question. As h approaches 7, 7's right here, the limit does not exist, or it does exist, it's approaching 0. Sorry. I was using my own question there. Okay, next question. Let me pull up another. That was number 50. Go with number 35. Now, read the question. It kind of helps if you read the question. X approaches -2 from the left. -2 from the left. What's happening? I'm approaching what? 3. So that would be 3. Let's do another one. All right, try this one. I'll blow it up. I'll make it bigger for you. I can't blow it up. It says limit of g of x as x approaches 1 from the left. 1 from the left. 1 from the left is right here. Sorry, positive 1 from the left. Positive 1 from the left is approaching 2. As you can see, they're not that difficult when you read the directions. Kind of nice to read the directions every once in a while. Let's look at 44. As I approach -1, what's happening when I approach -1? -1 is right here. I'm approaching +1 in the y direction. How you feel about that? I mean, I just did 4 of those. We good? Thumbs up, thumbs down. Okay, I got a couple of people. Thank you for the communication. Appreciate it. All right, that's 1.1. I'll give you 4 or 5 of those on the homework. I just don't want you to get discombobulated with these limits, and some of these questions can do that. 1.2. 1.2, let's see if we can, these are probably the algebraics. Ooh, this is a good one. I'm gonna let y'all do this one. So, go ahead. I can't blow it up because they don't let me blow it up on some of these homeworks. I'll write it down for the whiteboard for Mr. Bostic because he's not going to be able to see it. Limit as x approaches 3 of x cubed minus 27 over x minus 3. There you go. Mr. Bostic, you can go ahead and throw your pencil down. You won't know how to do it. You got to throw it down just like this. You got to make it pop. Ah, darn it, I can't. Like that. Y'all haven't never done that before, have you?
I've broken a few.
Yep. I turned over a desk and picked his 122 before we got thrown out of class. Do you know why? The negative coefficient in front of parentheses, I could not get in my head to distribute a -1. I could not get that in my head. It made me mad. That was when I was in earphone math. You know what earphone math is? That's when you can't take college classes and you got to put earphones on.
Mm.
I was Tri-County Tech earphone math.
Would this be 27?
Nope, this is shortcut number what? Shortcut number 5. X minus 3 times x squared plus, let's see, 3x plus 9 over x minus 3. And what happens to the x minus 3s?
Cancel out.
They cancel, and you're left with the limit as x approaches 3 of x squared plus 3x plus 9. 3 squared is what? 9 plus what? 3 times 3 is 9 plus what? 9. Is that what you were saying, Mr. Bostic? I'm sorry.
Yeah. Okay.
So then you are correct. But tell me what else you have to add to the problem besides 27.
The limit.
The limit is 27, but what? Come on, somebody help Mr. Bostic out.
X equals 27. I don't know.
Come on, but what? I just
circle
told
x
you not
equals
to
3.
forget to do this. But what?
An open circle at x equals 3
You
or a
got
vertical
an open
asymptote.
circle or a
Okay.
vertical asymptote at x is equal to 3. That's the answer. Now, of course, it's not sophisticated. I don't have my pinky up. There's some way you can write this with sophistication, but I'm not going to worry about it. Let's go to the handy dandy. Let's go to the handy dandy calculator. Y is equal to parentheses x cubed minus 27 over x minus 3. And I'm also going to put a vertical asymptote at x is equal to 3. Let's see what it looks like. Well, let me back up, zoom out. Let me do a zoom zoom fit. What is zoom fit? 0? Well, that's not right. Oh, okay. Let me zoom out. Zoom out. It's not supposed to be a parabola. It's a cubic function. Why is it not? Okay, needs to be open circle because you've got that x cubed canceling out with the x. There should be an open circle right here. So instead of drawing it like that, which is incorrect, you would draw it like this. And on standardized tests, this is the way they do it. I guess the vertical. Let me check and see if the vertical. I'm trying to get my calculator to pull back up. Yeah, y-intercept is 9. I just wanted to see where it was. And at x is equal to 3, 1, 2, 3, you've got a, that's what they want it to look like. Now, I'm not saying that they will ask for this every time, but if they do ask a question like, what else can you tell me about this function? You better remember that there is a vertical asymptote or an open circle at x equal to 3, because that's what they're wanting. Okay, so there's 2 answers to this. You got a limit of 27, but the vertical asymptote is at x is equal to 3, or open circle at x is equal to 3. Let's see what they ask. So this would be 27. Okay, this one doesn't ask for it, but there may be one that does. Okay, that's a test question. The one we just did and this one before it. Now you can't, you're going to have to play with this one a little bit, get rid of that radical, but you can do it with the shortcuts. But I'd put one of these on test and heartbeat. All right, let's see what's in the next unit, 1.3. I want to get to the difference quotient before we finish today. And these are just practical apps. I'm not going to worry about those. I doubt I'd put that on there. Okay, I'm not worried about these. You can read the graphs. I just want to see. Okay, we are going to do the difference quotient. So 1.3, that's where we actually start the difference quotient. So I'm going to grab a difference quotient right quick. And I'm not doing it their way. All right, here's an easy one. Let's do this one. Ignore this, okay? It says find a simplified form of the difference quotient and complete the following table. Well, we're just gonna do the difference quotient. So let's do the difference quotient on this one. And it's f of x is equal to -3. And we're talking out of 20 questions, you're probably talking about 4 or 5 on the test doing it this way. So f of x is equal to -3x plus 1. And I'm just going to go ahead and go to the whiteboard because I don't really care what they're asking. And I'm going to use an orange and a green. And m is equal to f of x plus h minus f of x all over h. Excuse me. Okay, go to it. I want y'all to do it. I'll give you a couple of minutes. Right at 3:30, we'll do it together. Do f of x plus h minus f of x, blah, 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 blah. Focus looks out of focus, or is that just the green marker? Must be the green marker. Mr. Bostic, I'm beginning to think that all the college teams are playing cupcakes. I didn't even watch a single ball game this weekend.
Yeah, I haven't either. Oh no,
I can't stand cupcake games.
That's one thing
I enjoyed Clemson and Georgia. That was almost like a bowl game.
Yeah.
I can't stand when they go against Burns High School.
Yeah, we go to all the home games. We go to most of the away games.
Who does Clemson play next?
Georgia Tech.
Oh, that's a thorn in Clemson's side. It's always been a thorn in Clemson's side.
So,
but
yeah, they'll be easy.
They still suck. They sucked last year. I don't know. They do any good this year?
I don't think so.
Okay, well then they're probably. Well, I guess I hadn't seen who I'm going to watch in the SEC. Georgia looked good. I'm going to swear Georgia looked good, but I don't know yet. Alabama has only played cupcake, so I don't know what they look like. I tell you, Alabama and Georgia usually take the SEC, but unless LSU or Auburn has a good year.
Yeah.
But nobody can beat the great one, Ohio State. They could be 0-14 and still be number 3. I never will understand that. That's been going on for 50 years.
My dad and uncle were on the team that we first beat them with.
Yeah, the one where I think Woody Hayes hit one of the players.
Yeah, that was
Ohio State, they one of the weakest conferences in the nation, and people think they're the greatest team to slice bread.
Yeah.
All right, so I'm going to rewrite 3x plus 1 with a big set of parentheses. And then I'm going to rewrite f of x in orange. And put a subtraction symbol in the middle. And an H on the bottom. And I'm going to plug in magenta. I'm going to plug in x plus h. All right, do your algebra if you haven't done it yet. Do it. Give you a minute. Yep, she's going to get him, so DSS won't pick him up. It's always good to stay away from DSS. Okay, so that's going to be negative 3x minus 3h plus 1 plus 3x minus 1 all over h. And the 3x cancels. The 1 cancels, and you're left with 3h. The h's cancel. Now I'm going to show you a trick I learned in the war. M equals 3, negative 3. What happens when limit h approaches 0? Well, if h was in here, it would take out the h, so the derivative is equal to negative 3. And when we get into 1.5, I'm going to show you 1 times negative 3 is what? Negative 3 x to the 1 minus 1 plus 0 times 1 x to the 0 minus 1. And what happens to all of this mess? It cancels. And x to the 0 is 1. And you're left with the derivative, which is negative 3. That's where we're heading. But we can't get to here without doing the limit. We have to do the limit. Now you see why the limit is semi-important. Do we need to spend 3 weeks on it? No. Do you need to understand that if you take half of a step of half of a step of half of the step, that you'll never reach the wall, but you'll get right up next to it? That's what you need to understand. All right, who's got a question? All right, let's do one more, just for good measure. Let's do one that, would make you, give up. It's always good to give up. I like to do a square. There's one. They just want you to plug in numbers. I don't care nothing about that. F of x is equal to 3x squared minus x. You might want to write small because this one might take a little bit of paper. So I'm going to let you start it.
Priority 1 message coming in on secured channel.
I don't know what that is. Okay, so I'm going to rewrite this with a big set of parentheses. Minus 3x squared minus x all over h. And x plus h goes in here and in here. So that will be that's going to be 3 times x squared plus 2xh plus h squared minus x minus h. I'm going to go ahead and distribute that negative. So that's going to be negative and a plus. That's going to be 3x squared and x. Actually, this should be green and this should be magenta. There. Now I'm going to distribute that 3 here. And that's going to give me 3x squared plus 6xh plus 3h squared minus x minus h minus 3x squared plus x. All that over h. And of course, at this point, you know that the 3x squared is going to cancel unless you did something wrong. And the x is going to cancel. Factor out of h, and you get 6x plus 3h minus 1 over h. And the h's cancel. And this is your answer algebraically. But when you plug in the limit, and I'm going to do this in a quirky color. Let me bling in. Let me bring in purple. Limit. Well, you can't even tell that's purple, so forget it. Let's just go with a pink. Limit as h approaches 0 of 6x plus 3h minus 1. And what happens to the h term if you plug in a 0 there? And your final answer, if you apply the limit theory, this is algebra. This, you apply the limit theory, and you're left with 6x minus 1, which is the derivative of this right here, which we're going to learn in 1.5. 2 times 3 is 6, x to the 2 minus 1, minus 1 x to the 1 minus 1. And that's going to be 6x minus 1. Okay, it's 3:42, and that's good enough for government work. I will put homework questions online tonight, probably up until 1.4, because 1.4 is difference quotient. So I will probably put questions up sometime tonight, and y'all just look for them probably before dark, at least before dark, hopefully. And let me take the roll and shut down the recording.